In this video, we're going to be talking about ionic compounds involving polyatomic ions. So polyatomic ions, as we recall from the previous slide, are just an ion made of more than one atom. So polyatomic means more than one atom, ion. So an ion made of more than one atom. And there are many of them. When I was in high school, I had to memorize, I think, around 20 of them. But I think we just have 8 here for us to work with, and that should be plenty of examples. So we're going to work to memorize these so we don't have to always refer to our notes. But since we probably don't have them memorized yet, I'm going to have them written along the sides here to refer to temporarily. And with naming them, it's going to be very, 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 very similar to how we were doing any other ionic compounds. So for ionic compounds, we are still going to name the first element first, and then the second element second, and drop the ending and replace it with "-ide" if the second element is a nonmetal. So let's do an example where we have that. So let's do one involving ammonium. So we're going to say ammonium, and let's do fluorine. All right, so we're going to have NH4, and we said fluorine. So keep in mind that NH4 has a positive 1 charge. If we look at fluorine, we know that fluorine, every element here is going to have a negative 1 charge. So fluorine has a negative 1 charge. And so we are going to get NH4F because, again, we have something with a positive 1 and something with a negative 1, and we're just going to kind of combine them together to form no overall charge. All right, but we're going to talk about how to name this. All right, so if we want to name this one, then if we want to convert this to a name, let's look at it. We're going to have ammonium, and we just said the second element is fluorine. But what did we say we're going to do to the ending? Instead of the regular ending, we're going to replace it with IDE. So ammonium fluoride. It's going to be the same case for anything else that starts with ammonium and ends with some other nonmetal. All right, so let's try now an example where instead of starting with the polyatomic ion, let's try ending with the polyatomic ion. So let's pull a metal that we want to work with, and then have the polyatomic ion act as our negatively charged ion, our anion. All right, so let's try a simple one. Let's do sodium nitrate. So we're going to do sodium. So we've got Na, and then we have nitrate. Nitrate has the formula NO3 1-. So we know that sodium, being in column 1, has a positive 1 charge, and nitrate, we just said, has a negative 1 charge. So we can do whatever method we want to figure out how many sodiums we need and how many nitrates we need, that being covered in the previous videos. But we can see that with a positive 1 charge and a negative 1 charge, they're going to cancel, and we only need 1 of each. So we get NaNO3. All right, and then let's name this. We're going to get sodium nitrate. And in my opinion, when we end with a polyatomic ion, those are the easiest ones to name, because look at what we're doing. We have the element sodium and the polyatomic ion nitrate. I don't have to alter either of those words in any way. All I need to remember is that the one that forms a positive charge goes first. So to remember that, maybe you can think that, think about what this symbol means. Has anyone ever seen this symbol? Well, when we named it, we think of it as, we call it plus or minus. That's what that symbol means. I don't know about you all, but I have never heard somebody call this a minus plus symbol. So think of it as the same way. We are going to name these. We're going to name the plus and then the minus, the positively charged ion and then the negatively charged ion. So think of the plus or minus symbol. I'll leave that written right up here. I don't know, in case it helps. But we always name the positively charged one first. So we have sodium nitrate, and we literally just leave everything the same. Sodium and nitrate. We don't alter the words at all. Let's try another one, and feel free, after I write it out, to pause the video and let me know, and try to figure it out on your own. Let's try, we could do a hard one. Yeah, let's do that. Let's do calcium. Let's do calcium, Ca, and phosphate. All right, calcium phosphate. Try that on your own, and then let me know when you're back. All right, let's assume that you're back. Okay, so we have calcium, Ca, and we said we're doing phosphate. So we're going to have PO4. And we need to know how many calciums and how many phosphates we need. So let's work out this problem below. So calcium, what charge does calcium form? What charge does calcium always form? It always forms a positive 2 charge. Phosphate, PO4, 3 minus, just by what it is, we know that it has a negative 3 charge. So I like to do the crisscross method. You're welcome to do whatever method you want to figure out how many calciums we need and how many phosphates we need. But what I'm gonna do is I'm gonna take this 3 and I'm gonna write it right here. And then I'm gonna take this 2 and I'm gonna write it right here. So that tells us that this is going to be Ca3 PO4 2. So I like to just leave the parentheses. First of all, I like to write it with parentheses, and then I usually like to leave the parentheses. Well, I don't know. I guess I don't always leave the parentheses. Notice how I don't have parentheses written on that one. You can leave the parentheses. You could just always write the parentheses, and that's fine. But typically, if there's only one of a polyatomic ion, most people don't write the parentheses. So since we have more than one PO4, we're just going to leave the parentheses and write the 2 outside of the PO4. That tells us that we have 2 PO4s, and this 3 represents that we have 3 calciums. All right, I'm going to change colors of this because this is kind of hard to see. Oh, I thought that worked. I guess that didn't work. 1 second. All right. So let me actually, all right, Ca2 plus, so that we can remember how we got those numbers. And then this 3 is from that right there. And now we can read it a little bit easier. I thought we were going to be able to. So we have Ca three PO42. All right, that's how we get that. Now, how do we name this? And this should be a little bit easier, actually. This should be a little bit easier than figuring out how many of each we need. So let's see. We have calcium and phosphate. So I think a pretty good name for that would be calcium phosphate. Again, when the anion, the negatively charged ion, is a polyatomic ion, we just write the whole name. So calcium phosphate. All right, we'll try one more example. This time I'm going to give you the polyatomic ion, I'm going to give you the compound's name, and then you're going to pause the video and try to figure out the compound. So we're going to do, let's try potassium sulfate. So let's do, I'm going to write the name, which is the easy part, and then you're going to do the harder part for me. Potassium sulfate. All right, so pause the video and figure out how many potassiums we need and how many sulfates we need, and then write it as a compound. All right, hopefully we paused the video and we determined that potassium, since it has a +1 charge, and sulfate, since it has SO4 2 minus, so it has a -2 charge, what we're going to do is we're going to take this -2, or we're not going to take the negative part. We're just going to write this 2 right here, and we're going to take the 1, and we're going to write it right here, except when we only have 1, we don't write the 1. So we have here K2SO4. And that is it. There are more examples in the other videos that are posted by Tyler Dewitt. Watch those for further clarification, but hopefully this helped. Let me know if there's any questions.